I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 25. This week, we are starting a new unit all about color.
Yay.
Cheryl, do you like colors?
I do like colors. My favorite color to wear is black, which I know is like, well, black's not a color, it's the absence of color. But like it, when I
some
choose
attitude there, jeez.
when I choose almost anything, I just think like if I have all the color selections, I'm like, yeah, but it looks better in black. So like for myself, I like black quite a lot. However, I appreciate colors when I see them in nature, when I see them on other people.
Yeah.
They're very fun.
They are definitely fun, definitely fun. And the day that our first color lesson is coming out is a day where we tend to see quite a bit of color, the 4th of July.
Yes, happy 4th of July. There's
Happy 4th of July.
Quite a lot of red, white, and blue going on. And so that's really fun. But then also tonight, hopefully everybody gets to go see some fireworks in some capacity. I guess it depends on where you live and if you're allowed to have fireworks in your area and everything. But I love fireworks so much.
Yeah.
They're so fun. They make me think of Disneyland quite a lot because they have really impressive fireworks shows, but also just like really lovely memories as a child on the 4th of July and like a neighborhood block party with our fireworks. And so, yeah, it's really fun that it's that time of year, but it did get me thinking, Ryan.
Yes.
How do fireworks work?
How do fireworks work? Is that going to be our first color unit question?
Yes.
Okay. Well, let's start as always with our pre-assessment. And I'm going to try and focus you in a little bit here first. When you say, how do they work? What do you mean by that?
like all of it? Like,
are you?
I know. Okay, here's what I know. I know the part that you light the end of it and then it like goes in the air and explodes.
Okay.
But like, I don't know why it explodes or what, like, or why it shoots off before I like really, I mean like the whole thing.
Okay. So you talked about a couple different parts. You talked about why it shoots off.
Yeah, like why doesn't it explode on the ground, which would be a big problem, and then we would not have fireworks.
Okay. Well, we would. They just wouldn't be up in the sky. They'd be on the ground. Yes,
but then they'd be like outlawed, and so we would not have fireworks.
Oh, yeah, we call that a bomb.
Yeah.
Right?
Okay. Yeah. So why do they shoot in the sky? But then why do they explode at all? Like, are they actually just bombs? Are fireworks just like bombs and canisters that we buy?
Okay.
Why are they different colors?
Okay.
Why are they different shapes? Why do some of them make noise like the piccolo Pete?
Okay, you're thinking of like the ones you can buy at the fireworks stand and light off yourself.
Yeah.
Right, the piccolo Pete, that's one of those, right?
Yeah, it makes like a loud shrieking noise that we liked when we were kids for some reason.
Yeah, I didn't ever, but there are people who do.
Although my favorite one was the one that then little parachutes came down from it and you could try to catch one.
Oh, I don't think I ever saw that one.
Yeah, getting prizes out of a firework, that was the way to go. That was fantastic.
Okay, let's talk about each of those categories that you mentioned then.
Okay.
What do you think causes them to shoot off into the sky and not just stay on the ground?
Energy.
Okay. It's a great place to start.
That's what I've learned from this podcast so far. So
Clearly there's some energy.
There's some form of energy. I really don't know, like, what would make it go up in the air? Like, is it the shape of the canister
Oh,
that,
okay.
like, shoots it off in a certain direction? Um, is it an added item that they put inside of the firework? Because it's not just like a bomb, but I don't really know how it's different than a bomb.
Okay. Okay, that's a
I
good
don't have
start.
much for that.
That's okay. It's a good start. And then once they get up into the air,
Yeah.
they explode. What do you think causes them to explode once they're up in the air?
Um, probably the same thing that makes a bomb explode, but I don't know what that is.
Okay.
Gunpowder? Is that what makes things explode? I know so little about bombs, Ryan.
That's probably an okay thing, Cheryl. And let's just say that it was the same thing as a bomb.
Yeah,
What would make a bomb explode?
I don't know.
Okay.
I have no idea.
Okay. And then the last part, color. And also you said shapes and sounds and things, but let's focus on the
Yeah.
color part of that. What do you think allows them to have different colors?
I mean, I'm gonna guess it's like different chemicals that burn different colors. Like when they burn, they create different colors. So then you just put whatever chemical you want that burns yellow in the yellow one or
Okay.
things like that.
Okay. And when you say that the chemical burns a different color, why do you think some things would burn yellow and other things would burn orange, for
Oh
example?
gosh, these are really great
And
questions
then
you
where would
have,
you get
Ryan.
like blue from or purple or
Um it's a wonderful question. I'm really glad that you're asking it on this podcast.
huh?
This is the right place for you to be asking it because I'm pretty sure the next thing that's going to happen is a lesson where we're going to learn the answers to some of those questions. I feel more clueless on this than honestly anything we've talked about. Like
Okay.
I know it has something to do with lighting things on fire and then when you do that I guess some things shoot off and explode and become colors.
And become colors.
Yeah.
Yeah. Okay. All right. Great. That's a wonderful place to start. Believe it or not, Cheryl, you have a fair amount for me to build on.
That's extra hard to believe this
I
week.
could tell. I could see on your face. You're like, uh-huh, you're just being nice. No, there actually is a fair amount. And we'll just go in the order that we talked about them before. So we'll start with what causes a firework to actually shoot up into the air in the first place. And the first thing you said was energy. And that is not wrong. I'm going to add more detail, but that is not wrong. There is energy involved. And you also talked about the shape of the canister, and that also is very important in what actually shoots
Really?
it. Yeah.
Yes.
See, I told you, you have more than you realized. And actually, you didn't talk about it in this section. You talked about it in the second part when what causes it to explode, but you were also right there which is gunpowder.
Really?
Yep, there is gunpowder. That is the big thing. But there's actually we can think of it as stages in a basic firework that launches up into the sky. You've got the gunpowder that's used to launch it, and then the gunpowder, once it's up in the sky, that you use to explode it.
Oh,
Does that
okay.
make sense?
Yeah.
There's two different parts. When you light the wick, or I don't know, fuse, whatever you want to call it, and then you run away so that it doesn't blow up on you, which is good.
How do you run away?
I don't know. What did I
Yeah.
do?
You did like Muppet hands and it was great.
I did
So,
Muppet
yeah.
hands. Okay. I don't 100% know what that is, but okay. Like Kermit?
Like you like run away. Yeah.
Run
You just
away?
looked like a Muppet in
Okay.
general. Yeah.
Well, I'll take that as a compliment because I love the Muppets. So anyway, you run away, and then the fuse burns into where that first little bit of gunpowder is. And then as soon as the gunpowder ignites and gets hot enough, there's a chemical reaction that happens that releases a bunch of gas very quickly, hot gas very quickly. And that gas expands rapidly. And this is where the shape of the container comes in. It's in that container, all of a sudden you have a huge amount of gas What do you think that does?
That forces the rest of the firework out and upward.
Yeah, it creates high, high, high pressure that, yes, literally pushes it out. So that initial expansion is to shoot the firework up. And it wouldn't do that if it wasn't in a small, particularly shaped container. So again, you were right. The container matters. So then it goes up. Congratulations. Then it goes up and there's more gunpowder there. Usually there's a sort of a secondary fuse or something that's also burning while it's on its way up. And once that one reaches wherever the inside of the firework is, there's more gunpowder there, and that actually ignites and explodes what's inside the shell that then explodes and lights up as a firework.
Cool.
Good so far?
Yeah.
Okay. Then it gets to, well, what about the parts that we actually see? So far, we just have gunpowder and more gunpowder, which is cool, makes loud banging noises, but doesn't look pretty.
Yeah.
Just makes a lot of smoke.
Yeah.
Right? The colors come from the elements that are inside that shell that gets shot up. Different elements, and when I say elements, I mean that in a chemistry sense, from the periodic table, actually have different characteristic colors. Once again, you said it was based on chemicals. And it is.
Yay.
But when I asked you why, you weren't quite sure, which is totally fine. I don't know if you ever did this in a science class, maybe in high school. Did you ever maybe take toothpicks and dip them in a liquid and then light them on fire?
No, but that sounds really fun.
Okay. Did you ever look at glass tubes with like funny glasses or like through a small hole and look at different colored lines?
Like personally, I might have as a child that little like glass tube, and then you like put the little glass thing through it, and when you look through it at different points, it like different things happen.
Are you thinking of a kaleidoscope?
I'm thinking of one that has a long, skinny, see-through glass circular container of some sort.
I think I know what you're talking about.
And you look, and then they put that through it like perpendicular.
Yeah.
And look at it.
That's not what I'm talking about.
Okay,
but that's also cool.
I mean, it was great.
But it sounds like you haven't seen this. Maybe
no, I don't think so.
Maybe we'll need to do a lab at some point on this, because I actually just, again, ironically did this with my students last week in astronomy, showed them some things, and there's some cool things you can do. Basically, each element, because of the number of electrons they have and the way those electrons can move when they get energy, can give off a very specific color. And those elements always give off those same colors, no matter where they are actually in the entire universe, which is why we talk about them in astronomy.
That's cute.
It is cute, isn't it? Let me give you kind of some of those ideas. For red, it's elements, some of these you have heard of and some of you haven't. Strontium, lithium, and those are the big ones, strontium and lithium. There's different kind of chemicals you can put them in, but those are the big ones, strontium and lithium. For orange, calcium. You've heard of calcium probably. For yellow, sodium. You've heard of sodium. As a matter of fact,
salt.
Yeah, well, yes, sodium chloride is salt.
Oh,
yes.
Okay.
But you may or may not have heard of it this way. We used to have a lot of street lights before LEDs became really popular because they're a lot more energy efficient. They had what they called sodium vapor lights, and they had sort of a yellowish orange tint to them, and they would usually hum pretty loudly.
Oh, yeah.
Does that ring a bell?
Yeah.
And it's using the same basic thing, except instead of lighting it on fire, it's running electricity through it. But it's the same idea, giving those atoms energy, and their electrons do all sorts of weird things, and they give off this particular color of light. Greens come from barium and chlorine. Barium you may not have heard of, but chlorine I know you have. Yep. Blue tends to come from copper compounds. And purple is usually a mixture of strontium and copper. Strontium was red, copper was blue. Ta-da, purple.
That's cool.
Yeah, so each of those elements has that unique combination. Depending on what colors they want the fireworks to be, they just put different of those chemicals that have those elements in them. And when they burn, they give off those colors.
Wow. So really the most impressive part of all of this is when those little parachutes come down. How did they not blow up at any of those stages?
Well, I don't actually know the answer to that because I'm not sure how those specific one works, but I can make a guess. Would you like me to
What's your
make an
guess?
educated guess?
Yes.
I think probably what happens is there are different, again, stages, but kind of containers in a sense inside the firework, the thing that actually gets launched up. And what probably happens is the little parachute thingies are protected by something that when the gunpowder goes off, it shoots them out and probably burns off or at least shreds the outside of whatever was holding that together, but it doesn't actually light it on fire. And then it's able to parachute down. It doesn't have these other things that are meant to burn when the gunpowder goes off.
Yeah, that could make sense. I could see that.
Yeah. And then the different shapes are all based on how you put each of those different components into the whole firework. You can actually put them in shapes. And if you arrange those different colored parts in a shape, when it explodes, it'll explode reflecting that shape.
That's crazy.
It is pretty
Because those
crazy.
smiley face fireworks are always, you're like, how? Or
Yeah.
like the one that looks like a cube.
Yep. They actually put the different little parts in the firework in that shape.
Wow.
I know, it's pretty crazy.
That's impressive.
Yeah. There's another YouTube video that does a really good job of explaining it. It's an actual fireworks chemist, a pyrotechnic professional. I'll link to it in our description and show notes. So if people want to go and watch that, it goes into way more detail about exactly how the big fancy fireworks work. And he's got one that he kind of did a cross sections. You can sort of see what it looks like. And
cool.
It's very, very cool. Very, very cool. But I think that's the basics of how fireworks work.
That's so cool.
Yeah. When you're watching your fireworks tonight, Cheryl, now you can be like, I know how that happens.
Yeah. We'll be like, go, chlorine, go. All those things.
All the things. And that means that now it's time for your first color quiz.
Ooh, is this first just where I say like blue makes Cheryl feel blue? Things like that.
I mean, you can say that. You did say that. But those aren't the questions I'm going to be asking you.
Okay, fine.
Although I could add one question like that to every quiz this unit if you want.
Oh my goodness.
Okay,
so
well,
good.
we'll see where we go. First question. What is the thing that makes fireworks explode?
Explode. Not shoot up in the air, but explode. Gunpowder.
Yes. Well, what's the thing that makes them shoot up in the air?
Gas.
That came from?
Gas expansion from gunpowder.
Gunpowder, okay. Yeah.
Okay.
Okay, great. And number 2 was, how do fireworks get up into the air?
The expansion of gas at a very quick rate.
Okay. And a follow-up with that, why does the shape of the container a firework is in matter?
Because that's going to determine which direction it gets sent, and probably that it gets launched in a certain direction at all, as opposed to just like flying all over the place. If it was in a ball, maybe it would just like explode right there, potentially. So it gets that long and skinny and just like heads it in that direction.
Yeah. Yep. It directs all of that explosive force. Yep.
Nice.
Okay. You're on a roll, Cheryl. Where do firework colors come from?
Elements.
Can you think of any examples?
Sodium or chlorine or lithium, which I know from batteries. Or a number of other elements, and they always burn the same color All the time, regardless of where in the universe they are.
Yeah, look at that. Good memory. How can fireworks have such cool shapes?
Because they're put into those shapes. Those elements are put into those shapes inside the firework.
Okay.
Which is honestly like the most like reasonable explanation. If you think about it.
Yeah. Before I knew that, it's for some reason in my head, I assumed there was some big complicated thing that led to it. And oh no, we just put it in that shape. Oh, I guess that makes sense.
Yeah. Yeah.
Okay, are you ready for your color question?
Yes.
What color do they like to paint hospitals because they claim it makes you feel calm?
Aren't hospitals white a lot of the time?
I don't know. I
Or
try
on
to
the
avoid.
inside?
Yeah.
Or inside or outside?
Inside.
Inside? Doesn't like blue make people feel calm?
I mean, maybe. That's not the color that I was told.
What color were you told?
Green.
Because it makes people feel calm.
Supposedly. I have no idea if that's true at all. You just put me on the spot to have a color question. So that's the first one that came to my mind. It could be totally wrong.
But somebody told you that at some point.
Yeah. Here, I'll look it up right now and see if it's true.
I've never even noticed a hospital room being green. I
haven't either.
Noticed white walls and curtains. That's what I feel like I've seen in hospital rooms. I mean, I guess I'm glad they're not painting hospital rooms red.
Yeah. This is from the Los Angeles Times and I literally just Googled it. And it's a quote that says, and since hospitals originally started with surgeries, that may well be the reason why green came to predominate hospital color in general.
Huh.
I guess a surgery room is sort of green. I guess. I don't know. I don't know. Hospital green is apparently a color. I have no idea if there's a real reason for it or if it's just because.
Interesting.
It could be total malarkey.
Could be
malarkey.
Listeners, you can write in. And
there you go. If you know the answer, let us know because we don't. But that's all the time that we have for this week's lesson about color. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.